So in continuation of the video part 6, we are going to discuss in this video, we are going to discuss about the algorithm types and the modes which is being used for the encryption and decryption process. Before going to discuss about the algorithm itself which is used for the symmetric cryptography, this algorithm types and the modes must be studied because it is the prerequisites of any kind of algorithm which is used in the cryptography. So, what is the algorithm types and the algorithm modes? So, these are the two aspects of any algorithm which is used for the cryptography. Now, as far as the algorithm types are concerned, it defines what size of plain text should be encrypted at a time. Meaning thereby, there are certain algorithm which implements a small data size of the plain text to be encrypted at a time, as well as a small data type in decryption at a time. So, and the algorithm mode defines the detail of the cryptographic algorithm once we are able to decide what type of algorithm we are using. So, as far as the ciphers are concerned, it is basically of two types, which is the mechanism by which we decide the process of encryption and decryption. The first one is the stream cipher, which is bit by bit encryption or the decryption. And second one is the block cipher, which is block by block encryption or decryption. So we will be using two types. One is stream cipher, another is the block cipher. So we have two types of algorithm, stream cipher and the block cipher. What this stream cipher stands for? In this, the stream cipher, the plain text is being encrypted 1 byte at a time. Only 1 byte is taken. Suppose we have in the plain text we have 64 byte. We have 64 bit. Suppose it means 64 bit is equal to 8 byte. So out of 8 byte, all the bytes are not encrypted at a time. Only 1 byte is encrypted at a time. Then the second byte, then the third byte, then the fourth byte. So of course, this type of stream cipher is applicable for small messages, or the type of the algorithm we are going to select, or the mode of the algorithm which we are trying to select, which works only on the byte by byte encryption or the decryption. So this is an example which has been shown here, in which we have a plain text as P100, that is an 8-bit information whose binary number is represented by this, and this is the plain text, and we are doing some operation so that it cannot be understandable, and after doing XOR operation with a certain 8-bit key, we are getting a ciphertext. Of course, that ciphertext will be like this. So P100 is understandable, but this is not understandable. So what does actually mean? That the stream cipher is a kind of a cipher in which 1 byte is being encrypted or decrypted at a time. So stream cipher technique involves encryption as well as the decryption of the text 1 byte at a time. But whenever we do the block of the data at a time for encryption and decryption, that is known as block cipher. So rather than 1 byte of the information or the text to be encrypted or decrypted, we take more number of byte, means it is block means 64 bit at a time. So 64 bit of the data is being encrypted or being decrypted at a time in the case of a block cipher. So block cipher technique involves the encryption as well as decryption of the text 1 block at a time, and the block may be 64 bit or more. Now, as far as the algorithm mode is concerned, it is a combination of the basic steps which requires or which uses some kinds of feedback from the previous step, and it is the idea just to add the randomness to the block cipher so that block cipher cannot be predictable. So we do some combination of some steps, and we take the feedback from the previous step so that the ciphers which are being produced are different and it is not recognizable by the attacker. So we have 4 different modes in which we used to work. One is electronic codebook, that is ECB. Second one is cipher block chaining, that is CBC. Then cipher feedback, that is third one, and output feedback, that is the fourth one. So we will discuss one by one the encryption as well as decryption of the different modes, how it works, what is the method of working in this particular mode. So first of all, electronic code book. Now, before going to discuss the electronic code book, we want to discuss the different modes which I have discussed right now, in which the first two one, that is the electronic code book as well as the cipher blockchaining. These two modes works on the block cipher, and cipher feedback and the output feedback. These two modes works on the block cipher, acting as a stream cipher. So this is the encryption process which used to happen in the ECB mode, that is electronic code book. This is the simplest mode in which we take the plain text block 1, we use a key, we use encryption algorithm, that is encrypt, and we are getting the ciphertext block 1. Of course, the size of the plain text blocks will be of 64-bit, the key size will be of 64-bit. We are applying an algorithm to encrypt this plain text message with the help of the key to get the ciphertext block 1. So second block will be encrypted by the same method, by the same key, by the same encryption algorithm to get the ciphertext block 2. And similarly, if we have such n blocks of the plain text, we apply, for all blocks, we apply the same size of the key, same encryption algorithm to get the ciphertext block. So plain text block 1 is converted into ciphertext block 1. Plain text block 2 is converted into ciphertext block 2. Plain text block n is converted into ciphertext block n by the application of the same size of the key. Same size of the key means the size equal to the size of the plain text. Plain text size is 64-bit, so key size is 64. And in every conversion encryption process, we are using same encryption algorithm and the same key bits are being used. So this is the step number 1. This is step number 2. So what we do in ECB mode, whatever is the size of the plain text, it is divided into 64-bit blocks, and each block is being encrypted at a time to get the ciphertext block 1, 2, 3, and so. So this is how the encryption process happens in ECB mode. Then we have decryption process in the ECB mode. Since I have told you that this is a very simple process, the process which is adopted in encryption, the same process will be adopted in the decryption also. But in case of encryption, plain text is the input. In the decryption process, ciphertext will be the input. Of course, in case of encryption, we will be using key and we are using encryption algorithm to get the ciphertext block 1. But in case of decryption, we are using same key, but we are using the decryption algorithm. Now, encryption algorithm and decryption algorithm is more or less same. The way by which encryption is being done, the same way decryption is being done, but in the reverse order. And with the help of ciphertext block 1, if we apply key and decryption algorithm, we will be getting the plain text block 1. So this is the thing which is being done by the sender, and it will use to send the ciphertext blocks to the receiver. Whenever receiver receives it, it takes the ciphertext block 1, applies the key with the help of decryption algorithm to get the plain text block 1, 2, and so on. But the problem with this ECB mode is very simple. Whenever two kinds of plain text blocks are same, then the same kind of ciphertext block can be received. So anybody who is sitting in between can have some idea about that what kind of plain text it will be, because since plain text blocks are same, then the ciphertext block will also be same. So we come with certain verification, some advanced thing in the case of CBC mode, that is cipher block chaining, in which some feedback is being applied. So what is being done, it is different from ECB, because ECB was very simplest one, and the demerit of that ECB is that if the plain text blocks are going to be same, it is going to give you the same ciphertext. But in case of, so the variation which has been suggested in CBC mode, why not to have a feedback, so that if we have, even though if we have same plain text blocks, we could get the different ciphertext block. And for that, an IV has been selected before the plain text has been encrypted with the help of key. Now, what is IV? IV is an initialization vector. Initialization vector is nothing but it is a random value which is generated by the sender. And first of all, whatever is the plain text size, the same size of the initialization vector is being considered. Suppose plain text block 1 is of 64-bit. So initialization vector is also considered of 64-bit. And this 64-bit initialization vector is first of all XORed with the plain text block 1 to receive certain value over here before it is being encrypted, and that value is encrypted with the help of key to get the ciphertext block 1. Now, whenever we receive the ciphertext block 1, it is received by the receiver. It will be sent by the sender. But before we are going to convert the plain text block 2 into the ciphertext block 2, this ciphertext block 1 is feedback to the plain text block 2 in the form of a IV, because ciphertext block 1 is working as an initialization vector in the second encryption part. So this ciphertext block is of 64-bit, that is working as initialization vector. It is being XORed with the help of XOR operation. It is XORed with the plain text block 2 so that we will have a 64-bit value over here, and then we will be using same key to encrypt it. And in this way, we are going to do the encryption process. So what does it mean? The plain text block is of 64-bit, ciphertext block 1 will be also 64-bit, but we will consider in the first step, we will consider a 64-bit random initialization vector number, and that is being XORed, and then it is being encrypted with the help of key, and then we are getting the ciphertext block 1. And this ciphertext block 1 is fed and XORed with the plain text block 2 to get some value over here as an input to the encryption algorithm. With the help of key, we are able to get the ciphertext block 2, which is again fed to the plain text block 3. After doing the XOR operation, we will be getting certain value that is being encrypted with the help of 64-bit key to get the ciphertext block 3, and so on. So this is how the encryption process used to happen in CBC mode. Now, in this particular case, even though the plain text block are same, but you will be getting different ciphertext block value. Why? Because this value is being, first value is being XORed with initialization vector. The second plain text value is being XORed with the first ciphertext value. Third plain text will be XORed with the ciphertext block 2, and so on. So even though if the plain texts are same, you are not getting the same ciphertext block. That is the good thing, which is the better than the ECB mode. Now, how the decryption process used to happen? The ciphertext block 1 is being the input. Now, first of all, we will decrypt the ciphertext block 1. Now, this is just the reverse process, whatever we are doing in the encryption mode. In encryption mode, what we are doing, we are XORing IV with plain text block 1 to receive certain value over here, and then it is being encrypted. Now, whenever it is being decrypted, the decryption process, first of all, we will decrypt with the help of key, and then we will XOR with IV to get the plain text block 1. Now, we are using here the property of the XOR. The property of the XOR says that if we have a number, 8-bit number, and it is being XORed with another 8-bit number to get the certain result, if the result is being XORed with the same value which we have XORed in the previous one, we will get the same value. So, if the ciphertext is being decrypted by the key, and then whatever is the resultant, it is being XORed with the initialization vector, we can get the plain text block 1. Now, this ciphertext block 2, it will be decrypted first, and then it is being XORed with the ciphertext block 1 to get the plain text block 2, and so on. So this is all about the CBC mode, which is different from the ECB mode. And this is the encryption process of the CBC mode, and this is the decryption process in the CBC mode. Now, these two processes which we have discussed, ECB and the CBC, both works on the stream cipher. But there are certain possibility that we have certain algorithm which does not support the block ciphering, and it works on the stream cipher. So for that particular, the first mode which works is the cipher feedback mode. Now, very carefully try to find out try to listen that how the encryption process used to happen in CFB mode. Now in this CFB mode, again we are taking the initialization vector, and this initialization vector, whatever size it may be, whatever size of the key, suppose it is 64-bit, so initialization vector or the shift register is also of 64-bit. Now this initialization vector is put in a shift register, and this is initialization vector value is being encrypted with the help of key, and we will be getting certain 64-bit value over here. Now out of that 64-bit value, we take just the leftmost 8-bit, and after taking the leftmost 8-bit, the plain text will be of J bit, that is 8-bit, and that is being XORed. And whenever these two values are XORed, whatever is the resultant, that will be the ciphertext bit. So we are taking IV as 64-bit, key as a 64-bit, encryption has been done. Whatever is the resultant, we take only leftmost 8-bit, and that leftmost 8-bit is being XORed with the plain text 8-bit to get ciphertext 8-bit. Now the second phase, second part of this is this ciphertext 8-bit, which is the first 8-bit, it is being shifted into the shift register from the left hand side. So what happens in the initialization shift register, we previously have initialization vector. Now this initialization vector value is being shifted 8-bit left to receive this ciphertext. So this initialization vector value and this initialization vector value will be different. And now this is being encrypted with the help of key. We take the leftmost bit, it is being XORed with the second plain text to get the second ciphertext, and so on. So this is how the encryption in the CFB mode used to happen. Now, can you consider what will be the decryption process in the CFB mode? Decryption process is very much similar to the encryption process in the CFB mode, but a very little change in this particular diagram. And now, in this encryption process, we are getting ciphertext from the plain text. We are getting ciphertext from the plain text whenever it is being XORed with the leftmost 8-bit after the encryption process. It means whenever we have to find out the plain text from the ciphertext, we have to XOR this ciphertext with this value, same value, to get the plain text. And this is the only difference which will happen in the decryption process of the CFB mode. Let us see what is the picture, what is the diagram of the decryption in the CFB mode. Now you see, the only change which has been done is the ciphertext is the input and plain text is the output. Rest of the things remain same. Here you will be confused, or you will be thinking that why it is the encryption process. Even though we are doing decryption in CFB mode, even though we are using encrypt process. Now let us first again take the idea of encryption process. Now it is the 64-bit IV which is being encrypted with the key to get certain value, and out of that value only taking 8-bit value and XORed with the plain text value to get the ciphertext. So it means whenever we have to find out plain text from the ciphertext value should be XORed with the same value so that you are able to get the plain text because of the property of the XOR. So to obtain the same value over here, so that whenever it is XORed with the ciphertext, so to get the plain text value, thus this process should remain same, and that is why the decryption process has this value as same value, same steps which is being used. The only difference encryption and decryption lies that ciphertext is the input in case of decryption and plain text is the output. But in case of encryption, plain text is the input and the ciphertext is the output. The rest of the things remains as it is same. And the same ciphertext is being fed into the IV register to get encrypted. Take the leftmost bit. Again, we are taking the ciphertext bit to get the plain text J bits, and so. So this is how the cipher feedback mode works. The last one is the OFB mode, that is output feedback. Now the problem with this ciphertext CFB mode is, if by the way there is certain change accidentally, unknowingly or knowingly, we are shifting this ciphertext bit into the CV register. If this shifting of this ciphertext bit in the IV register gets some distortion due to some reason, we are not getting the same value of the ciphertext feeded back into the IV register, then in that case, while doing the decryption, you are not able to get the same plain text. So just to avoid this particular, because it is going to propagate, if there is an error in the ciphertext, it is going to propagate in the CFB mode. Just to avoid this propagation of the error, encryption in the OFB mode has been made. And what is the process which is being adopted in the OFB mode? This is the simple as the CFB mode that we are taking IV, that is initialization vector register. It is being encrypted with the key, similar to the CFB mode. Taking the leftmost 8 bit again. After this, leftmost 8 bits are being XORed with the plain text to get the ciphertext. In the CFB mode, you have seen that ciphertext is being fed in the IV register. But in OFB mode, this leftmost 8 bit is being fed in. So ciphertext is free. So if there is any error in any ciphertext, it is not going to propagate. So this value is fed into the IV register. It is being shifted left and 8 bit has been included so that you will be getting new IV value. Again, it is being encrypted by key, taking the leftmost bit, again being XORed with the plain text to get the ciphertext, and so on. So this is how the encryption in the OFB mode used to work. Now, can you guess that what could be the decryption process in the OFB mode? Yes, very true. The same way the difference in between encryption and decryption of the CFB mode, the same way we are doing the encryption and the decryption in the OFB mode. What we have to do, ciphertext will be the input and plain text will be the output. So let us see what happens in the decryption mode. Ciphertext is the input and the plain text is the output, and the rest of the process and the thing will remain as it is. So this is how the ECB mode, CBC mode, CFB mode and OFB mode, these are the algorithm modes in which the different algorithm used to work. Now after this, we will be discussing the algorithms which are used for the symmetric cryptography. Of course, we are repeating the same thing, but same key is being used for the decryption, and the different cryptographic algorithm which lies under the category of the symmetric cryptography is the DES, that is data encryption standard, the IDEA, RC5, Blowfish, AES, advanced encryption standard, and these are quite popular as well as very fast also. So this is the illustration of the symmetric cryptography where the sender is having some plain text. It encrypts the plain text with the help of the symmetric key to receive the cipher, to get the ciphertext, and this ciphertext is sent on the network. Through the network, the ciphertext is being received by the receiver. It decrypts with the symmetric key to get the plain text, and it is being received by the receiver.